Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, students, subscribers, viewers, and future engineers. Here is another set of problems, exercise problems for you to watch or for you to solve. If you want to solve these problems by your own, then you can do so by pausing the video and not looking at my presented solutions here. So that's a good habit for you to develop your skills in calculus. So for problem 27, for the function y equals square root of 2 minus 3x, so problem 18, show that the derivative does not exist at x equals 2/3. Problem 18, this is already 27, so you just look at problem 18 if you cannot obtain the derivative of this function using limits. But the derivative was negative 3 over 2 square root of 2 minus 3x from problem 18. So, and let us show that the derivative does not exist when x is 2/3. So we substitute the value of x. So negative 3 over 2 square root of 2 minus 3 times 2/3. Take note that 3 times 2/3 is 2. So 2 minus 2 is 0. So this becomes negative 3 over 2 square root of 0. But square root of 0 is 0 and 2 times 0 is 0. Remember that in algebra, division by 0 is not defined. Because this is not defined, that's the reason why the derivative of this function y equals square root of 2 minus 3x does not exist when x is 2/3. So that's it. That's the showing that the derivative of y equals square root of 2 minus 3x when x is 2/3 really does not exist at x equals 2/3. 28. For the function u equals t to the 3 halves, so problem 24 showed that the derivative does not exist at t is 0, but the right-hand derivative exists at that point. So this is the derivative of t to the 3 halves, t to the 1 half from problem 24. So for the left, there are two meanings of the derivative using limits as t approaches to the left and to the right. And for the limit to exist, both left and the right hand limits must be equal, or else the limit does not exist. So when t approaches 0 from the left, we substitute 3 over 2 square root of 0 from the left, and this is negative value. Square root of a negative value is not defined again, so that's the reason it is not, the left hand limit does not exist. Then the right hand limit, as t approaches 0 from the right, so 3 halves of square root of 0 from the right, and square root of 0 from the right is 0. So the value 3 times 0 over 2 is 0. The right hand limit exists and its value is 0. It exists. But the derivative of the function does not exist when t is 0 because the condition is for the limit to exist, both the left and the right hand limits must exist and are equal to each other. Since only the right hand limit exists, so in general, the derivative of u equals t to the 3 halves when t is 0 does not exist, but the right hand limit exists. 29 to 33, derive the formulas for the derivative of the following trigonometric functions, which are very useful later on in your study of calculus. So there's a need to derive this using limits because that's the original tool. So derivative of y equals sine x. I'll just repeat this. So y equals sine x, y plus delta y equals sine of quantity x plus delta x. So two things that must be put in mind and required in this problem in order for us to derive the derivative of y equals sine x. One is the expansion, uh, sine of alpha plus beta. You should know that. And the second one is this guide formulas here, that the limit of sine delta x over delta x equals 1 as delta x approaches 0. You just review the earlier part of limits and the derivation of this formula. So limit of sine x over x as x approaches 0 is also 1. Limit of quantity 1 minus cosine delta x over delta x as delta x approaches 0 is 0. You just also look at the derivation or showing that this is equal to 0. And limit of 1 minus cosine x over x, which is the same form as that, as x approaches 0 is 0. Of course, limit of sine x or sine delta x as delta x approaches 0 is 0. Limit of cosine delta x as delta x approaches 0 is 1. Those are additional tools which you must know. So y plus delta y equals sine of quantity x plus delta x. So delta y equals, I'll expand this, which is sin cos plus cosine. So sine x cosine delta x plus cosine x sine delta x. Then minus y, which is minus sine x. So delta y, therefore, for the first and the last terms, common is sine x. So we have sine x quantity cosine x minus 1. Then I just copy the second term here, cosine x sine delta x. Dividing everything by delta x, then we'll have, I change the sign instead. We factor out negative 1. So this becomes 1 minus cosine delta x. Then this is after we divide delta x plus cosine x sine delta x over delta x. We divide everything in the right side by delta x. And I shift, instead of sine x, or I factored out negative 1, so negative sine x, then we'll have 1 minus cosine delta x. Since the limit of, since dy dx is limit of delta y over delta x as delta x approaches 0, and this is 0, the limit is 0, and this is 1, then we'll have negative sine x times 0 plus cosine x times 1. Therefore, the derivative of y with respect to x, the derivative of sine x with respect to x is equal to negative 0 or 0 cosine x. So it is cosine x. Derivative of sine x is cosine x. And from now on, you must be able to memorize that formula, because later on, we differentiate functions directly using these formulas, especially functions that involves trigonometry. 29a y equals cosine x, so y plus delta y equals cosine of quantity x plus delta x. The expansion of cosine of x plus delta x is cos minus sin. So delta y is cosine x, cosine delta x minus sin. Sine x, sine delta x, then minus y, which is cosine x. So minus cosine x. Common to the first and the third term is cosine x, but I make it negative cosine x instead, so that it becomes quantity 1 minus cosine delta x. Then I just copy the second term minus sine x sine delta x. Dividing everything by delta x, then we have negative cosine x, quantity 1 minus cosine delta x over delta x, minus sine x times sine delta x over delta x. dy dx is limit of delta y over delta x as delta x approaches 0. So that's the limit as delta x approaches 0 of this delta y over delta x ratio. And take note that this is 0 again from this guide formulas here, this is 1. So it is negative cosine of x times 0 minus sine x, which is negative sine x. Derivative of cosine x, therefore, is negative sine x. And you must memorize this. 30, y equals tangent x. So y plus delta y equals tangent of x plus delta x. Expansion of tangent x plus tangent of quantity x plus delta x is tangent x plus tangent delta x over 1 minus tangent x tangent delta x. So delta y is this, which is the expansion is this, then minus y, so minus tangent x. By algebra, LCD is 1 minus tangent x tangent delta x. Then we'll have tangent x plus tangent delta x minus tangent x times this LCD. So it is negative tangent x times 1, so negative tangent x. Negative tangent x times negative tangent x tangent delta x is positive tangent square x tangent delta x over the LCD. So we can cancel tangent and tangent x and negative tangent x. So we have two terms left in the numerator in which tangent delta x is common. So we have tangent delta x, quantity 1 plus tangent square x all over LCD, which is 1 minus tangent x tangent delta x, which simplifies to tangent delta x because the identity of 1 plus tangent square x is secant square x. So I replace this by secant square x over 1 minus tangent x tangent delta x. So dividing everything by delta x, delta y over delta x equals tangent delta x over delta x secant square x all over LCD 1 minus tangent x tangent delta x. I break tangent delta x into sine delta x over cosine delta x. Then we have 1 over delta x secant square x over 1 minus tangent x sine of delta x over cosine delta x. We may not break this, but also remember that limit of tangent delta x as delta x approaches 0 is also 0. But I only mentioned limit of sine delta x as delta x approaches 0, which is 0, and limit of cosine delta x as delta x approaches 0, which is 1. And you may include limit of tangent delta x as delta x approaches 0 equals 0. By the way, let's just proceed. So delta y is 1 over cosine delta x. Then let's form this ratio, sine delta x over delta x times secant square x all over 1 minus tangent x sine delta x over cosine delta x. So delta y over delta x is equal to dy dx is limit of delta y over delta x as delta x approaches 0, which is the limit of this ratio because limit of cosine delta x as delta x approaches 0 is 1. So it is now this. Actually, uh, from here, we can proceed. From here, we distribute cosine delta x into the denominator. So that's why we have sine delta x over delta x times secant square of x. Then cosine delta x times 1 is cosine delta x. Cosine delta x times tangent x sine delta x over cosine delta x cancel cosine delta x. So what is left is negative tangent x sine delta x. So dy dx limit of delta y over delta x as delta x approaches 0 is the limit as delta x approaches 0 of this expression here. Remember, this is 1. Limit of cosine delta x as delta x approaches 0 is also 1. Limit of sine delta x as delta x approaches 0 is 0. So it becomes 1 secant square x over 1 minus tangent x times 0. So the denominator is simply 1. So the derivative dy dx reduces to secant square x. So the derivative of tangent x with respect to x is secant square x. And you have to remember that. 31y is cotangent x, which is 1 over tangent x. So y plus delta y is 1 over tangent of x plus delta x. So delta y is 1 over tangent of quantity x plus delta x minus 1 over tangent x. Simplify. So delta y is 1 times tangent x, so tangent x minus 1 times tangent of quantity x plus delta x over LCD tangent of quantity x plus delta x times tangent x. Simplifying, we have tangent x. The expansion of tangent of quantity x plus delta x is tangent x plus tangent delta x over 1 minus tangent x tangent delta x, all over same expansion, then times tangent x. Simplifying, tangent x times this, 1 minus tangent x tangent delta x is tangent x minus tangent square x tangent of delta x, then minus tangent x minus tangent delta x all over this denominator. In the denominator, the LCD is the same, all over tangent x times tangent x tangent square x, then tangent x times tangent delta x all over 1 minus same denominator tangent x tangent delta x. So we can cancel this denominator. We can also eliminate tangent x and negative tangent x. So in the numerator, negative tangent of delta x is common. Then we'll have negative tangent delta x times quantity tangent square x plus 1 all over, copy this denominator, tangent square x, tangent delta x. Divide everything by delta x, so delta y over delta x is negative 1 over cosine delta x. By the way, sine delta x over cosine delta x, that's the tangent delta x, and the negative sign is also written. This is now the delta x that is divided to both left and right side of the equation. Then we have secant square x all over, we just copy the denominator. So dy dx is the limit of delta y over delta x as delta x approaches 0. So the limit of this as delta x approaches 0, and remember, limit of sine delta x over delta x is 1, and limit of cosine delta x as delta x approaches 0 is 1, and limit of tangent delta x as delta x approaches 0 is 0, which I mentioned earlier. So dy dx is negative 1 over 1 times 1 times secant square x, and secant square x is 1 over cosine square x all over tangent square x plus tangent x times 0. So dy dx is negative 1 over cosine square x, then divided by tangent square x, and the reciprocal of 1 over tangent square x is cotangent square x, which is cosine square x over sine square x. We can cancel cosine square x, so it reduces to negative 1 over sine square x. And negative 1 over sine square x is negative cosecant square x. So therefore, the derivative of cotangent x is negative cosecant square x, and you must memorize that. 32, y is cosecant x. We write that as 1 over sine x, reciprocal of uh, cosecant x is 1 over sine x. Cosecant x is also 1 over sine x rather. So y plus delta y is 1 over sine of quantity x plus delta x. So delta y is 1 over the expansion sin cos plus cosine. So sine x cosine delta x plus cosine x sine delta x minus y, which is 1 over sine x. So by algebra, sine x times 1 is sine x. Then negative 1 times this, so we just copy negative of sine x cosine delta x and negative cosine x sine of delta x all over LCD, which is this denominator as product, sine x cosine delta x plus cosine x sine of delta x times sine of x. Common in the first two terms is sine x, so we have to factor out sine x. So delta y is sine x, quantity 1 minus cosine delta x, minus cosine x sine delta x, we just copy. All over LCD, also copied. Divide everything by delta x, so we have delta y over delta x is sine x, then 1 minus cosine delta x over delta x, because that is written as product. It may be sine x over delta x, but we should put it here because there's a formula for the limit of this ratio. Then minus cosine x sine delta x over delta x over LCD, which is just copied. So dy dx is limit of delta y over delta x as delta x approaches 0. We limit as delta x approaches 0 of delta y over delta x, which is this. And remember, this is 0, this is 1. Limit of cosine delta x as delta x approaches 0 is 1. Limit of sine delta x as delta x approaches 0 is 0. So simplifying, dy dx is sine x times 0 minus cosine x times 1 over sine x times 1 plus cosine x times 0 close times sine x. So that reduces to negative cosine x over sine x times sine x. And we rewrite it into negative 1 over sine x, negative 1 over sine x, this one, and quantity cosine x over sine x. 1 over sine x is cosecant x, cosine x over sine x is cotangent x, so the derivative dy dx is negative cosecant x cotangent x. The derivative of cosecant x, therefore, is negative cosecant x cotangent x, which you must memorize again. Then finally, y is secant x is 1 over cosine x. So y plus delta y is 1 over cosine of quantity x plus delta x. So delta y equals 1 over the expansion of cosine quantity x plus delta x is cos minus sin. Cosine x cosine delta x minus sine x sine delta x. Then 1 minus 1 over cosine x. This is the LCD. Then cross multiply. So we have 1 times cosine x minus 1 times this denominator. So you just change sign, negative cosine x cosine delta x plus sine x sine delta x all over LCD. Common in the first two terms is cosine x, so factor out cosine x, quantity 1 minus cosine delta x plus sine x sine delta x over LCD. So dividing everything by delta x, delta y over delta x is cosine x, quantity 1 minus cosine delta x over delta x plus sine x times quantity sine delta x over delta x all over LCD. So dy dx is limit as delta x approaches 0 of this ratio delta y over delta x. And again, this is 0. Limit of this ratio is 1. Limit of cosine delta x as delta x approaches 0 is 1, while limit of sine delta x as delta x approaches 0 is 0. So that reduces to cosine x times 0 plus sine x times 1 over cosine x times 1 minus sine x times 0 close times cosine x. So which simplifies to sine x over cosine x times cosine x. Rearranging, so we have 1 over cosine x times quantity sine x over cosine x. 1 over cosine x is secant x, sine x over cosine x is tangent x. Therefore, the derivative of secant x is secant x tangent x. To summarize, because you need to memorize the derivative of these basic trigonometric functions, if y is sine x, the derivative of y with respect to x is cosine x. If y is cosine x, the derivative of cosine x is negative sine x. You must close your eyes so that you can memorize this. I'm also closing my eyes. Derivative of tangent x is secant square x. Derivative of cotangent x is negative cotangent x cosecant x, or negative cosecant, derivative of y equals cotangent x is negative cosecant square x. Derivative of tangent x is secant square x, positive. Derivative of cosecant x is negative cosecant x cotangent x. And finally, the derivative of secant x is secant x tangent x. So that's it for this video because it is now lengthy.